In this video, you will get a detailed overview of the new and powerful automation tool called Keptn, which is actually an open source CNCF project. Keptn is an SRE and DevOps tool, so if you don't know what SRE is, make sure to watch my recent video on SRE because it will make it way easier to understand Keptn. First, we will understand the problem Keptn tries to solve in the release process, and then see in detail how Keptn works by looking at the three main use cases of Keptn of automated delivery, automated operations, and automated monitoring. We will look at Keptn's architecture and visualize how a more efficient and automated release process can look like with Keptn. And at this point, I want to thank Dynatrace for sponsoring this video. So let's get started. Let's say we have the following release process. We have an e-commerce application and we develop a really cool new feature and we want our application users to use that feature. So we start the release process. We commit the code changes, which triggers Jenkins build. Jenkins runs the tests, builds a new Docker image and pushes to Docker registry, and then deploys to a Kubernetes cluster development environment. Well, that's pretty cool, but our goal isn't to deploy to development. The goal is to deliver the change all the way to the end users, because they should see the new cool feature. So we want the code changes to be deployed to production. But before that happens, we need to test the changes extensively to really make sure that our new feature doesn't break the whole application in production, because then users will see nothing, and we don't want that, obviously. So our release will go through the stages. Like first we run automated tests, for example, functional tests on the development environment to make sure the new feature addition didn't break anything in the application. Now, in many cases, engineers can't 100% rely on automated tests only. So manual tests are done in addition to really make sure everything works as expected. Now we're ready for the next stage, like staging, testing, pre-prod or hardening or whatever you may call it. So we deploy the feature to this next stage. Let's say in our case, we call it staging. On dev environment, we ran functional tests to make sure everything functions properly. Here we can focus on performance of the application and run performance tests, like how does application handle high load of traffic or how fast it responds to user requests and so on. Again, automated tests may not be enough, so quality engineers may do extensive manual evaluation to check application performance, look at the test results and compare to the previous builds. Also go through checklists and some predefined release criteria to make sure that application meets all these criteria. And only after that, if everything is fine and the test results are good, the feature will get a green light for deployment to production. Now, even after such extensive testing, there is always a little bit of risk that something will go wrong in the actual real environment in production, especially in a very complex, huge application with lots of dependencies. So we don't just throw the new application to the production environment, like deploy a new version, remove the old one, and switch all the traffic to it immediately. No, instead, there are deployment strategies to do this more safely, like blue-green or canary deployment, where we basically deploy the new version and show it to some users to test that everything is fine, run it for a couple of hours, maybe even days, observe and monitor it closely, and be ready to roll back the new release anytime if something goes wrong. And eventually, if everything works fine without any issues, we switch 100% of the traffic to the new version, and then we can get rid of the old version. So as you see, this whole process involves a lot of manual work of monitoring, testing, and evaluating on multiple stages. And as you may imagine, this may take days and weeks for a completed feature to finally get to production safely. So a lot of human work is involved here, but what's also important to mention is how many tools and technologies are involved in this whole process. As a central piece of this whole release process, you have a CI/CD tool like Jenkins that needs to integrate with various other tools like packaging tools, different testing tools, Docker registry, deployment tools for Kubernetes, like Helm, and so on. So you have this complex pipeline that has lots of integrations, and each integration that needs to be managed, upgraded, and so on. Plus, you may even have a lot of custom logic for doing various things that none of the plugins or services help you with. And usually in a company, you don't have just one such pipeline, you have a separate pipeline for each and every application or project team. And these pipelines may be only slightly different from each other. Like one team may need a higher version of Helm and they need a different Docker registry than the rest of the teams, etc. So in this case, it's hard to consolidate and reuse the pipelines. So all the teams have to configure and maintain their own pipelines. So what do we need to make this whole process faster and make the pipelines much more manageable? Well, first of all, we need automated evaluation between the stages instead of manual checks. Automation makes things faster, so we want to replace the slow human work with fast automated process. And second, we want to be able to create reusable pipelines which make it much easier to integrate and plug in different tools and replace those tools for different teams if they want to. And that's exactly what Keptn does and helps you with. So how does Keptn help you solve all these challenges? First of all, Keptn lets you define a high-level workflow for your release. Like how do you want to deploy your application changes? Like what stages, what test and deployment strategy for each stage, and the evaluation between the stages. And it lets you define this workflow easily in a declarative way with YAML in a shipyard.yaml file. Now, note that there is no mention of the tooling here. So who is doing the deployment or who is executing all these tasks, like running the tests or actually deploying to a specific stage and so on. So Shipyard defines what needs to be done, but where do we define how all this should be executed? Well, those tasks are executed by different tools. For example, Helm will do the deployment to Kubernetes, JMeter and Selenium will run the tests, and so on. But how does Keptn talk to these services? How do they know that they should execute a specific task? Well, Keptn uses events to communicate with various tools to send them tasks to execute. So for example, when it's time to execute a deploy task, Keptn will trigger an event saying, deploy this service with version 1.2 to development environment with direct deployment strategy. Now, on the other side, you have these tools configured that can execute the tasks. But how do these tools know how to handle the event? So for example, if you use Helm for deployment, how does Helm know to listen for this specific event and then execute deploy task? Well, that's done through Keptn services, which are basically small applications written for each tool that can translate the Keptn event into an API call to that specific tool. So Keptn's Helm service will subscribe to execute deploy event, read the event payload when Keptn sends it, and then translate that event into a Helm task and tell Helm to deploy the application with the provided information. And there are Keptn services for various tools that you may need in your pipeline. But what if you're using a tool for which there is no Keptn service, or if you're using a custom tool? Well, Keptn actually offers a more generic way to integrate with different tools using webhooks or Kubernetes jobs. So you have all this flexibility as well. So as you see, the workflow definition and the tooling is separated. That's on purpose to separate concerns. So Keptn basically gives you a tool to orchestrate other tools using events. This means instead of a code integration like with Jenkins, it works based on events. And this makes tool integration with Keptn very flexible. And because you have separated the release workflow and the tooling, you can replace any tool without changing anything in your workflow. If you want to use a new tool, just set it up, subscribe it to the relevant event, and that's it. If you want to stop using a tool, unsubscribe it from the events, and done. Another big advantage of Keptn's event-driven approach is that you have a more efficient workflow execution. For example, when you start a Jenkins build that runs 5-hour tests, you will have Jenkins agent blocked for 5 hours until the test execution is finished. So other builds will have to wait for it. With an event-driven workflow, you don't have to wait for the tasks to finish. You make asynchronous calls. Instead of polling the tool to see if it's done, the tool itself responds back with an event saying, I'm done, I've completed my task. So whether the task takes 10 minutes or 5 hours, it doesn't matter because nothing gets blocked. Okay, so Keptn helps you create more flexible pipelines that are easier to manage and easier to integrate with different tools. But that's not the main advantage of Keptn. I mentioned that it helps automate the evaluation steps between the stages, and that's the cool part. So Keptn replaces the human quality gates that do checks and evaluations based on tests to decide whether the change can pass the gate to the next stage, and uses automated quality gates instead. So in the workflow, we would have deployment, tests, and evaluation. And we saw that different tools can do deployment and test, but which tool does the evaluation? Well, Keptn actually comes packaged with a service called Lighthouse service, which does the evaluation. So you get this functionality out of the box with Keptn. You don't have to install and configure these services, which is pretty cool. So how does that work? How does Keptn automate this extensive application evaluation process? To understand that, first of all, let's see what goes into the evaluation process itself. Let's say we ran performance tests for 3 hours, which generated traffic for the application, basically simulating the actual usage of the application and its features, like in a real prod environment. Now, the application performance can be evaluated based on these test results, like how quickly the application handled requests, how many errors the application produced, was the application overloaded at some point, like did we have spikes in the CPU and RAM usage, etc. And there are monitoring services like Prometheus, Dynatrace, etc. that collect such metrics. So while tests are running at the same time, a monitoring service like Prometheus collected metrics for the application during these 3 hours. So these metrics must be evaluated to see how application performed. But what's also important, they must be compared with the previous releases. So basically we want to know, did the application get slower compared to the previous releases? Did it have more errors, or did the application performance actually get better? So we need a history of evaluations. So as you see, for a proper evaluation, we need these two things: metrics from the monitoring tool like Prometheus, and we have to decide what metrics do we want to evaluate. And these metrics are called SLIs, or service level indicators, because they indicate how a service is performing. And we define this list of metrics for Keptn in a file called sli.yaml. Again, declaratively in a YAML format. And the Lighthouse service that you get with Keptn then fetches these metrics from the monitoring tool. And as I mentioned, this could be performance metrics of how the application is performing, but also it could be security metrics, like what security vulnerabilities were identified in the application. As a second step, once we have the metrics or SLIs, we want to now evaluate them. Are they high, low, good, or bad? So how do we define what's good or bad? We define this with what's called service level objectives, or SLOs. For example, we define that a response rate below 100 milliseconds is good. So the objective is to have a response rate below 100 milliseconds. So that's one type of evaluation of taking the metrics and comparing it with absolute values. But with SLOs, we can also evaluate the comparison with the previous releases. So for example, does the application respond faster or slower than in the previous 3 releases, for example? So we can define that also as an SLO in Keptn. And for each SLO evaluation, Keptn calculates a score, and we can define all this in an SLO.yaml file. Now, as I said, based on that evaluation, we decide whether the release can go to the next stage through the quality gate or not. So the evaluation result must be a simple yes or no, or pass or no pass. So what does Keptn give us as a result of evaluation? It gives us a score, a total score of all the SLO evaluations. And based on that score, we can define in the SLO.yaml file whether it's a pass or not. For example, if we get a total score of 90% or more, the release can pass through the gate. Now, 2 points I want to mention here about Keptn workflows and how it works. First of all, as you see, everything is defined declaratively. The shipyard workflow, the SLOs, the SLIs, so all the configuration of Keptn is declarative. The second is that it follows GitOps practices, which means all the logic and definitions and configuration are stored in Git repositories, and every change that Keptn makes is updated in these repositories and stored as a single source of truth. So basically, Keptn forces you to use some of the best practices in the DevOps and SRE field when you use it. Now that we know what Keptn actually does, let's see how an example release workflow will look like with Keptn. So we commit and push our new cool feature. This triggers a Jenkins build, which builds and pushes a Docker image to the Docker registry. Now Keptn comes in to take over orchestrating the deployment all the way to the production. So Jenkins sends an event to Keptn to start the release process. Keptn starts the release workflow defined in shipyard.yaml file. So Keptn triggers the event for the first task, like deploy to development with a direct deployment strategy for this service with image version 1.2. So all this information will be in the event. A Helm service that is listening for that event will say, I can do that, and deploys the new version to the development environment. Once Helm completes the deployment, it sends back an event to Keptn saying, I'm done, here are the results of the deployment, or the status of the deployment. So Keptn now triggers the event for the next task defined in the workflow, like run functional tests on the dev environment. And in this case, let's say 2 services, JMeter and Litmus service, are both listening for this event. So they both start executing the tests, and once done, both send events back to Keptn saying the task is completed. Now, if any of the tests have failed, Keptn will abort the release because it means there is some issue in the changes. If not, it continues with the workflow. So as a next step, Keptn triggers an event, start evaluation. For this, as I mentioned, Keptn has its own service, so you get this functionality out of the box. So Keptn's evaluation services will fetch the metrics or SLIs, calculate the SLOs and the total score, and send back an event to Keptn with that final score. And if the score failed, Keptn will abort the release process. If it passed, then the next task will be executed to deploy changes to the staging environment using a blue-green deployment strategy, and so on. So this workflow continues all the way production if everything along the way, all the tests and the evaluation processes are successful. And if not, Keptn can abort the release process at any stage or task. So we have a completely automated multi-stage release process. Another interesting question regarding Keptn is, where does Keptn actually run? The control plane of Keptn, which basically orchestrates all these tools, triggers the events, etc., runs on Kubernetes. So you deploy it inside the Kubernetes cluster using a Helm chart or Keptn CLI that will again use the Helm chart in the background. And the execution plane or services that execute tasks based on Keptn events can run both inside the Kubernetes cluster or outside the cluster, like Jenkins or Selenium service, for example. And you can even have multiple execution planes connected to the same control plane of Keptn in order to manage multiple environments like dev, staging, and prod, or even multiple cloud environments. Now we have deployed our cool new feature all the way to the production using Keptn. Is this the end of the release cycle? No, because as I said, no matter how much you test and evaluate, there's always a slight possibility that in actual real environment, things will be slightly different. And then we get a problem in production. Let's say we released our new feature, which is part of the shopping cart service, to production just in time for a holiday where you expect lots of sales. The application runs for 7 hours and we have shifted 100% of traffic to the new version. And by midnight, something breaks in the shopping cart service. So people can't buy stuff, they can't add anything to shopping cart. Super bad situation because you're losing a lot of sales on a holiday. Well, normally you would have some kind of monitoring and alerting configured in your cluster that gets triggered automatically and sends notification to the team members that there is an issue in the cluster. For example, the alert manager is configured to alert when response duration increases considerably, or a certain service is not responding at all. That means support gets a call at midnight to investigate and fix the issue with the new feature, and if they can't fix the issue, to eventually roll back to the previous working version or remove the feature flag and deactivate the new feature. So what are the challenges here? Well, obviously, again, we have the human element, which means the support engineers getting calls at night to fix major issues in production and the effort in fixing these problems. And that's another use case of Keptn to help you with what's called automated operations. So Keptn can be used to automate this process as well. So how does that look like? With Keptn, you can define what's called a remediation sequence for production issues. So you create a YAML file with steps to fix the issue. So how does the workflow for this look like? Alert Manager detects an issue and sends an alert that shopping cart service isn't working, like it's super slow or it's not responding at all. So Keptn receives this alert as an event. Again, everything is event-based with Keptn. And based on that alert event, Keptn starts executing a remediation sequence which you defined to fix the issue automatically. For example, the first remedy step in the sequence is to scale up the pods, because maybe the current number of pods cannot handle the traffic, so we distribute the traffic a bit among more pods. This means Keptn will send an event, scale up pods for this shopping cart service. The same way as we saw before, a Helm service is listening for this event and will say, I can do that, and scale pods by changing the replica count. When it's done, report back to Keptn. Now this is an interesting part, because we don't know yet that this remedy step actually fixed the problem, right? So we need to check and observe to see whether the issue was actually fixed. So Keptn does that for us by waiting for the change to take effect, and then it will evaluate the SLOs to see whether the metrics have improved. So the same evaluation process as in the quality gate is used here, and based on the evaluation score, Keptn will know whether the problem was fixed or not. If yes, everything's cool, problem fixed, we can configure Keptn to send a fixed notification to the team. If not, Keptn will look at the next remedy step and execute that. For example, the next step could be to remove the feature flag. And again, Keptn will do the evaluation to see if this action fixed the issue. If the remedy sequence didn't fix the issue, it can then escalate it to the team and then someone can intervene manually. But as you can imagine, you could cover already a lot of error fixing scenarios with these automated remediation steps without needing a human intervention, which is obviously a huge improvement of operations. And finally, we saw that throughout the whole release process of not only automatic deployment, but also after deployment operations in production, monitoring and alerting is a central core point of this whole thing. Because without the metrics, we can't do the automatic evaluations or remediations. So configuring, monitoring, and alerting for your applications is an important component for this whole process. And Keptn actually also helps you with that. You can use Keptn to automatically configure monitoring and alerting tools for you. For example, based on the SLI.yaml files that you have defined for your services, it will know which metrics you want to track. So it can configure the scraping endpoints to collect these metrics data from the monitoring tool. The same way, based on the SLO.yaml files, it will know what the accepted values for these metrics are. So it can automatically configure alert rules for when the values are off or not within the accepted range. I hope you learned a lot in this video, not only about Keptn, but also about new concepts around SRE in general. Definitely let me know in the comments what you think about Keptn. And also, if you want to learn more about Keptn, they actually have few tutorials with different workflows to play around on their website. Or you can even check out their Slack channel if you want to join the Keptn community. And with that, thank you for watching and see you in the next video.